Hi everyone, in this video screencast I'm going to demonstrate the fixed point iteration for x equals gx method. Let's begin by entering our function fx, and we have x cubed take away 3x plus 1 is the form that I'm going to use, plus 1, okay, and we might want to zoom in. Now we also have this can be rearranged into y equals x, and we also have g of x, okay, which is one possible rearrangement, and we'll choose it to be x cubed plus 1 divided by 3. So let's put in x cubed plus 1 and put that in a bracket, and do divide by 3. Now we have a line and two functions, so it's probably good to color code these. The main interest in this process is actually the gx and the y equals x. Okay, so the fx is just there just to show us where the roots are. So let's select this and turn it a different color. Let's turn it red, and also the style, let's give it a dotted line and make it a bit thinner. Okay, so there's our fx. Okay, now we've got g of x, and similarly let's do that. Now let me just turn on the grid over here. So we've got g of x. I can click on that. I can either go to object properties or simply change it from here. I'm going to turn that green. Okay, and then I've got y equals x, and I'm going to turn that blue. Right, so it's easier to see the difference between them. We need to annotate our graphs, so I'm going to do that now and insert a text. So the first one, let's put in y equals x over here. We probably need an arrow, so let's put in an arrow and just say that y equals to x. Okay, need a capital y equals to x. I'm going to click latex formula. It just gives a better look to the equation, and in fact it's a bit small, so let's make that medium. Okay, we can make it large if needed, maybe larger better. We'll keep to medium. Right, so there's our y equals x. We have fx over here, so let's define that, and another text box. Okay, so I'm going to say y equals to f of x, and just to make things clear, I'm also going to put the formula, which I've already put in, so, and that's object f. Okay, and again I'm going to click latex. You probably need a an arrow, so let's put in an arrow over here. Do okay. There you go, and let's make that medium again. Okay, so there's our fx, and finally we should also label our g of x. Let's put in another formula, another little text box. So click on text box and just put down y equals g of x. Okay, and this equals, maybe put a new line. This equals, and let's put the object in, and that's g. I get it, like if I click on the latex formula, it actually puts it in a nice form for me. So I'm going to click OK. Now maybe it's good to put in an arrow, so let's put in an arrow, and as follows, and make that medium. Okay, now I can see I've used a capital, so I'm going to go back and take away this capital, and there you go, that's better. It's automatically changed that in the formula because it's a dynamic application. Right, now what we want to show is that where the roots of fx occur are actually the points where g of x intersects with y equals x. So what I'm going to do is, one of the ways we can illustrate this, here's our roots for fx, is I can actually use this function here where it's a point of intersection, and I'll click that and the x-axis, and these are now my roots. I can see that y equals 0, and I've got 3 different x values, so they're the roots of fx. Now if I do the same thing, so I've got the intersection button on, and I'm going to choose g of x and also click y equals x, it gives me another set of points d, e, f. Now we can see quite clearly that where at points d, e, f, the x coordinates coincide with exactly the same as a, b, and c. And we can obviously make a note of that by maybe putting another text there, just to say y equals x and y equals gx intersect where fx equals to 0.